Hi guys, so in this lecture we'll be talking about Saytzeff versus Hoffman alkene. Okay, so we have Saytzeff versus Hoffman alkene. Okay, now we have NME3 as a very good base. Now you must remember that if a substance is a very good base, then it would be a very weak leaving group. Okay, now having said that, let's take some example in which we have attached NME3 to a product or to a compound, and we need to find the product when it actually reacts with ETO minus, and we are providing some heat to it. So obviously E2 elimination will take place, and we find out that this is the Hoffman alkene and this is the Saytzeff alkene. Hoffman and Saytzeff. Okay, so the yield of Hoffman alkene in case NME3 was used as the attached group was 95%. When SE2 was used, then the Hoffman percentage was 74. When F was attached, it was 70, and when BR was attached, it was 30%. Okay, so why does this happen? If you look at the reaction mechanism of E2 reaction, it's a one-step reaction, right? In which base would be attacking on the or forming a bond with the alpha hydrogen from the organic compound and from this compound, and at the same time the leaving group would be detaching itself from the carbon atom, and at the same time double bond character or alkene character would be between the alpha hydrogen and the beta hydrogen. Okay, so all these things happen in the one step only, but when we have a strong base or a weak leaving group, as in case of NME3, what actually happens is the alkene or the carbon atom gets a negative charge so as to force uh, the leaving of or cleavage of this bond. Okay, but in if but in the but had it been a good leaving group, then actually that kind of carbonyl character is not required, because the cleavage of the bond happens at the same time and no driving force is required. In case of strong living in case of weak living groups, a driving force or a carbonyl character is needed so as to push the cleavage of C and the living group, and at the same time make the double bond between the carbon atom or the carbonyl and the alpha carbon atom, as in this case. Okay, so what happens if ETO minus um, extracts hydrogen from this position, then this carbon atom would get a partial delta negative charge. Okay, and if it actually attacks on this carbon atom, then this carbon atom would get a partial negative charge. Okay, so in this case we'd be seeing the stability of the carbonyl hence formed in the intermediate or in the transition state. Hence carbonyl formed at this carbon position would be more stable than this carbon position. Why? Because it is having attached plus I groups to each to itself, right? And which is not there in this case. Hence carbonyl would be more stable at this position. Hence ETO minus will attack on hydrogen from this carbon. As a result, we'll get a negative charge here, and this negative charge will push the bond cleavage between C and weak leaving group. Okay, as a result, there will be double bond character here, and in the product as well, Hoffman would be seen as a product having high yield, as high as 95% in case of weakest leaving group or weak leaving group. Okay, so just remember the format that weak base, this implies strong good leaving group, Okay, so now let us see how what I have talked about the transition state. So the transition state in the above example would look similar to this. We have, this is the, I'm marking this as the alpha position, and we have n plus me3 here. Oh, I forgot to make n plus here. Yeah, so n plus me3, and we have ch2 here. So what happens is this hydrogen atom will be getting detached with the and getting attached with the O delta minus et. Okay, and we need a strong delta minus here so as to enforce a double bond character in this bond and to slightly cleave this bond. Okay, so for this thing we need a partial negative charge here, hence ETO minus will attack on this carbon atom rather than this carbon atom. Okay, and another important case which we see is, suppose we have something like this, and it is getting reacted with something like this. Okay, so what happens in this case is, if you look at the Hoffman and the Saytzeff product, in the Hoffman product we get something like this, and in the Saytzeff we get something like, okay, so this is the Hoffman product and this is the Saytzeff. Okay, so what actually happens here is, the yield of this reaction when this is taken as the, or better let me write it here, when this is taken as the reagent, then we get something like this. Yeah, when this is taken as the reagent, the Hoffman product is 72%. If we take something like this, the Hoffman product is 77%, and if we take like this a reagent, then the Hoffman percent is 78%. Why is the case happening? Obviously, one obvious reason is steric hindrance. Okay, these bulky groups are very much finding a hard time attacking or forming a transition state with this alpha hydrogen. Okay, because it is highly sterically crowded position. So what they do is, the least sterically crowded position for the alpha hydrogen is this, hence they all attack on this alpha hydrogen and form a transition state which gives these bulky groups room to or space to adjust themselves and attack or cleave the CH bond. Okay, so this is also a rule. Okay, so we write some very important rules here in case of Saytzeff and Hoffman products. That first is, we get carbanion character in transition state in case of poor leaving group. Okay, and second is, in poor leaving groups, base attracts that beta hydrogen which forms stable carbanion. Okay, in poor leaving group, base attacks that beta hydrogen which forms stable carbanion. Okay, And third point is obviously Hoffman products, Hoffman alkene is favored when A, there is a poor leaving group in the compound, and B, strong sterically hindered base such as tertiary butoxide is a reagent. Strong sterically hindered base such as tertiary butoxide. Okay, so with this we come to an end of this lecture. In the next set of lectures or in the next coming lectures, we will be seeing some more examples on identification of major products when different reagents are passed on to react with substrates. Okay, till then, good luck and goodbye.